All right, so what we're looking at right now is how to divide polynomials using synthetic division. So this is another method other than long division, how to divide polynomials. So the process is here. You guys can look at that later. I'm just going to roll through it, and you guys will catch on pretty quickly, I think. Let's see. All right, so all we have to do is take our two equations. We need to check on two things. We need to make sure we're in standard form, and that we're not missing any variables. So any terms we're not missing. So we did the same thing with long division. And then the third thing, I guess, is the number we're dividing by, or the polynomial we're dividing by, has to be linear for this to work. Just to keep it easy, I'm going to say only use these on x minus a number and x plus a number. So you don't have to remember too many things. So the first thing we do is look at our coefficients of the polynomial that we are dividing into. So we write our coefficients. So 2, -10, 1, and -5. And then over here, draw like a little sideways L, and then we're going to put our x-intercept in here. So it would be a +5, because if we were to set this equal to 0 and solve for x, we'd have a +5. And now we drop the first term down. And then what we're going to do right here is we're going to multiply these two numbers. So 5 times 2 be 10. And now we're going to add vertically. So -10 and 10 is 0. We're going to continue on this process. We're going to multiply 5 by the next number. So 5 times 0, 0. Add. So 1 and 0 is 1. And then we're going to multiply again. So 5 times 1 is 5. So that goes here. And we're adding, and we get a 0. So as long as we get a 0 here, this means no remainder. And what we do with these numbers, we're dividing a x to the third by an x. So that result would be an x squared. So these numbers down here are coefficients of our answer. So we get 2x squared plus 0x, we don't need to write that, plus 1. And then if we had a remainder, we would write it in remainder form. But this would be our answer right here. Let's try another one. I'll go through it a little quicker this time. So we're dividing by -3, because that's our x-intercept. 3, 8. We're missing an x, so we put a 0 as a placeholder, like we did with long division. First term always drops down. -3 times 3, -9. Add them, we get -1. -3 times -1 is 3. We add, and -3 times 3, -9. Add them up, we get 5. So as long as we have that placeholder, and we're going to have the right answer. If we don't have it, it's going to be something completely different. So now we take these. We went x cubed divided by x, so we started with an x squared. So 3x squared minus x plus 3 plus, we have a remainder of 5 divided by what we were dividing by is x plus 3. So this is our answer. Go ahead and try those checkpoint problems. Alright, so we were dividing by 1. We get 9, -7, and 3. 9 drops down, 9 times 1, add, and then 1 times 2, add. So x squared divided by x, that's going to be x, we get 9x plus 2 plus 5 over x minus 1. Then the next one, we go 3. We got a 1, a negative 2. We're missing an x squared, so we go 0, 3, negative 36. So 3 times 1, add them up. 3 times 1, add. 3 times 3, add, and 3 times 12. We get 0 there, so 0 remainder. So we're going x to the 4th divided by x, so we should end up with x cubed as our first term. So 1x cubed plus 1x squared plus 3x plus 12. No remainder. So there's our answer here. Alright. So same idea here. So use synthetic division to show that x plus 3 is a factor. So as long as you divide and you get 0 as a remainder, then it is a factor. So I'm going to do, let's do this one. Let's do B. It's the same process over and over. So we're dividing by negative 3 because that's what we would get as our x-intercept. So we go 1, 5, 8, 3. Multiplying. So this time we're not writing out a polynomial as an answer. We're just looking at our remainder. Is it 0 or is it not? So right now it's not 0, it's negative 3. So that means that x plus 3 would not factor in evenly to our given polynomial. Okay. I guess we can do this one real quick. So negative 3 again. Write out our coefficients. Drop down, we're going to multiply. So we're looking at, remember, our remainder is 0, so this is a, yes, x plus 3 would factor in evenly to our given polynomial. Alright, so go ahead and pause and try those real quick. So negative 2, 2, and we have a missing x. So we go 0 there. So you can probably already see what's going to happen here. So our remainder tells us that not a factor. I forgot to write the 2. So we go 2 into 4, negative 3, negative 8, and negative 4. So we get 0 as a remainder, so it is a factor. Okay. Last thing we need to talk about, synthetic substitution, also known as the remainder theorem. So this says if I plug in a value into the equation, we get an answer. The remainder is our answer. Sorry, a little early. So we want to evaluate our function at 4, so x equals 4. We want to find out what the value would be. So this is a quick and easy way, and I told you that there was a little trick to evaluating polynomials earlier in the year. So this is an x equals 4, so we need to take a 4. We don't take the opposite because it's not in factored form. It is an x value. So listing out our coefficients, so we're just doing division. So if we were to evaluate this function, the answer would be p of 4, evaluating our function at 4, we get a 7. So a coordinate would be 4, 7. X value is 4, y value is 7. All right, go ahead and try that checkpoint. I'll skip over that one. All right, substituting in negative 3. 1, 3, missing an x. So multiplying it out, 0. And then get 4. So p of negative 3 would be 4. All right, so just to save time on the video, we'll skip over that question down here at the problem, but you're doing the same thing. You're plugging in and evaluating. If you have any questions, please let me know, and we can talk about those later on. Have a good one.